Hello guys, in this video I will solve questions about finding limit at infinity. So what is limit at infinity? It means as the x values are heading towards positive or negative infinity, the function is increasing or decreasing without bound. So the value that function is increasing or decreasing without bound will give us the answer. So such answers will be giving us the horizontal asymptotes. For example, in this graph, as x values are heading towards positive infinity, the function is approaching to uh, this fixed line y equals 3. As x values are getting very small, the x values are getting smaller and smaller and smaller as it goes to the left, then function is heading towards so this fixed line, which is y equals 3. So limit as x approaches to 3 from infinity, positive infinity of f of x, the function is heading towards 3. Similarly, as x values are getting very small, going to the left, to the negative infinity, then function is approaching to 3. So this is what limit at infinity is. This is when x values are increasing or decreasing without bound, heading towards positive or negative infinity is called limit at infinity. And whenever there is limit at infinity, the value of the function that the function is approaching is called horizontal asymptote. Okay, so this line, this invisible line, horizontal line, will give us horizontal asymptote. So in order to find the horizontal asymptote, we just need to check limit at negative infinity and positive infinity. For some questions, we have the same value as x approaches to negative or positive infinity. For some other questions, we have different values, so we need to check both. For example, in this question, as x approaches to positive infinity on the right, function is heading towards to this invisible horizontal line, which is y equals 0. As x approaches to negative infinity, function is approaching to 0. So from right and from left, we have the same value. So our horizontal asymptote is y equals 0. On the other hand, another example for this function, as x values are getting bigger and bigger and bigger, approaches to positive infinity, function is approaching to this line whose value is 2. As x values are getting smaller, heading towards to the negative infinity, then the function is approaching to negative 2. So we have two different values from right and left. We have two different horizontal asymptotes then. Okay, so if question is asking about horizontal asymptote, this is what we need to do. Find limit at infinity 1 by 1. Okay, let's remember this note. We studied this before. So non-zero number over infinity is 0, right? Number over infinity will give us 0. Check it out. 1. Find the limit at infinity. So all we have to do is whenever there is limit, we do direct substitution. So it's gonna be 5 minus 2 over square root of infinity. Here I have number over infinity, which is 0. 5 minus 0 is 5. So this is the answer. What if question asks about horizontal asymptote? In this case, we would say y equals 5 is the horizontal asymptote. Another note that will help us to solve questions easily. When you find an indeterminate form, 0 over 0 or infinity over infinity, then divide the numerator and denominator by the highest power of x you find in the denominator. This is a way. We have two ways of solving infinity over infinity or 0 over 0 questions. We either use L'Hopital's as first way, or divide top and bottom by the highest power of bottom. Let me apply the first way. This question gives us infinity over infinity. When I apply L'Hopital's, I will get, take derivative of top, which is 6x minus 2, derivative of bottom, 4x plus 3. I still have infinity over infinity case, so I have to use L'Hopital's one more time. So take another derivative, derivative of top, 6, bottom, 4, 6 over 4, 3 over 2 is the answer for this question. What if you want to use the other way? It is not necessary, but for some question it is essential to know this way, because by using L'Hopital's we cannot solve every question. So let me explain the second way too, in case you cannot solve questions by L'Hopital's. Limit as x approaches to negative infinity of, divide everything by the highest power of x, which is x squared in the denominator. 3x squared over x squared minus 2x over x plus 2 over x. Do the same for the bottom. 2x squared over x squared plus 3x over x squared minus 2 over x squared. Now distribute the limit. X squareds will go, so limit as x approaches minus infinity of 3 minus x's will go, limit as x approaches to, sorry, this is x squared, one of the x's will remain at the bottom, plus limit as x approaches to negative infinity of 2 over x squared. At the bottom, x squareds will cancel, just have 2 plus x's will go, 3 over x minus, now let's answer the question. Limit as x approaches to negative infinity of 3 is 3. Limit as x approaches to negative infinity of 2 over x, when you insert the infinity it is 0. When you insert the infinity it is 0, so we have just 3 at the top. At the bottom we have 2. Limit as x approaches to infinity of 3 over x, number over infinity 0, number over infinity 0, so the answer is 3 over 2. As I said, there will be some questions that cannot be solved by using L'Hopital, so we need to know this way too for some other types of questions. Okay, partial test 6a. Find the limit. When I insert infinity, I will see infinity over infinity case, which will lead me to use L'Hopital's. So let's apply L'Hopital's. Take derivative of top, 2 comes down in front, multiplied by derivative of inside, over derivative of the bottom, 4x. Do I have the same situation? Do I have infinity over infinity again? Yes, I do actually. So I have to do L'Hopital's one more time. Derivative of top, negative 2 times 2, negative 4. Its coefficient stays, times derivative of 1 minus 2x is minus 2, over derivative of bottom is 4. So answer is minus minus plus 2. So this is the answer for this question. If the question is asking about finding horizontal asymptote, it would be y equals 2. Another partial test question, an administrative exam question. When I insert infinity, what happens? Limit as x approaches to negative infinity of 1 over infinity. which will be 0, minus, let's distribute this limit to the bracket, limit as x approaches to negative infinity of 1 plus limit as x approaches to negative infinity of 3x. So here I have 1, right? Limit as x approaches negative infinity of 1 is 1. And when I insert infinity here for x, it's gonna be negative infinity. So negative 1 plus negative infinity, it's gonna be negative infinity. So the answer of this question is negative infinity. If it was about finding the horizontal asymptote, since infinity doesn't represent a real number, we would say no horizontal asymptote. Another partial test question and a ministry question. When I insert infinity, I will get infinity over infinity. I should apply L'Hopitas. But first of all, I should get rid of this absolute value. How do I get rid of this? When I pick a negative value, then inside absolute value will be negative. So when I take x minus 2, absolute value x minus 2 out, I will take its opposite, negative x minus 2. So this is how we remove the absolute value, and then I can apply L'Hopitas. Derivative of top is 4x, bottom is negative 1. When I insert negative infinity back, it's going to be negative infinity over negative 1. Negatives cancel each other. It's gonna be positive infinity. If it was about finding horizontal asymptote, there wouldn't be any horizontal asymptote. So that's all for now.